What is the shape of the universe? Flat, spherical, or like a saddle? What shape is the universe? The question itself doesn't seem to make much sense if, as NASA says, the universe is simply everything, including all space and all the matter and energy it contains, and even time itself. Does this everything have a form? If you are reading this text, perhaps you are one of those who is willing to contemplate the inconceivable, visualize the unimaginable, and spy on the impenetrable. In other words, he behaves like a cosmologist, one of those theorists who try to present credible and sustainable ideas about space, a fact that has occupied thinkers for centuries. For them, the shape of the universe is a serious matter, as it implies the future of the cosmos. Depending on what it is, we will know whether it will expand forever, or reverse its expansion in a cataclysmic big crunch, or great implosion or collapse. Furthermore, knowing the answer to the question in question gives clues as to whether the universe is infinite or finite. So how do you begin to solve this riddle? With Albert Einstein, the idea that space had shape emerged with the 1915 theory of general relativity, and from all the ways it could be considered, this theory only allows the universe to assume one of three. One of them is that it is curved and closed, like a giant expanding sphere. Another is that it is hyperbolic, overtly curved, the opposite of a sphere, something like a horse saddle. Then there is the flat hypothesis. The cosmos is like a sheet of paper, except it has more than two dimensions. Einstein left three possibilities regarding the topic. One of the factors that determine the shape it takes is its density, that is, the amount of matter in a given volume of space. If it is too large, the force of gravity will exceed the force of expansion and it will curve into a sphere. If this were so, the universe would be finite, although it would have no end, just as the surface of a ball is not infinite, but there is no point on the sphere that can be called the end. In addition to being finite, this is the scenario in which the expansion will stop at some point. The galaxies, instead of moving away from each other, will begin to move closer together, until what began with a Big Bang ends with a great collapse. In the other two cases, the hyperbolic and the flat, the universe is infinite and will expand forever. To establish what it is like, and the future of the cosmos, solid observational evidence is needed, but for what? Well, something believable. The oldest light. Cosmologists have measured the cosmic microwave background radiation, the cold remnants of the Big Bang, about 13.8 billion years ago. These traces of when matter, space and time formed, according to the standard cosmological model, are easy to find, says physicist and author Marcus Chown, because they are literally everywhere. If you take a cubic centimeter of empty space anywhere in the universe, it contains 300 photons, light particles of this radiation. In fact, 99% of all the light in the universe is not that of stars or anything like that, but the glow of the Big Bang, he said. It was something discovered in 1965 and it's like a photo of the newborn cosmos. It's the oldest light, and when we capture it with our telescopes, we look back as far as we can. Encoded in this light is a picture of the universe as it was a third of a million years after the Big Bang, a pivotal point, as it was when the first structures, the seeds of galaxies, were formed. These traces of radiation are often described as the cosmologist's Rosetta Stone for deciphering the past, allowing researchers to make detailed deductions from the sparsest observational evidence. How can so much be inferred from the fossil radiation of the Big Bang? The universe could be shaped like a horse saddle, according to research, making what some have described as the most difficult measurement in science. The light from the Big Bang, that can now be seen in a sphere surrounding the Earth, is in the form of very short waves, microwaves, and is a mixture of light and residual heat, extremely weak, although enough to suggest powerful ideas. It's like a uniform layer with a nearly constant temperature of about 3 degrees above absolute zero, minus 273.15 degrees C. Theoretical astrophysicist Dave Spergel explained to the BBC. The interesting thing is in the almost small variations of up to 100,000ths of a degree from one place to another. That's what they measured, because, when we look at the microwave background radiation, we learn about the geometry of the universe, explained he, who is known for his work with NASA's MAP probe, launched in 2001 with the mission to study the sky and measure these temperature differences. It was one of several studies that helped determine the shape of the universe. But how can observations of light particles from the Big Bang help astrophysicists like Carlos Frank of Durham University decide what their shape is? That's the beauty of science. We can make very important inferences based on very detailed data. These particles of light have been propagating over billions of years, until they reach our telescopes and follow whatever curvature may be present, he said. Depending on how they arrive, experts say, it is possible to find out how the trip was. And would the universe be flat? Researchers trying to reach an accurate conclusion. Imagine these cosmic microwaves as two rays of light. In a flat universe, they will always remain parallel. In a spherical universe, they will travel along the curvature of space and eventually meet. In a hyperbolic universe, the rays will never cross, and will become increasingly separated. And it turns out that they remain parallel. The first time the shape and fate of the cosmos were reliably inferred from observations was in 2000, when an international team of astronomers from Italy, the UK, the US, Canada and France, known as the Boomerang Collaboration, published the results of the year study. I think this is the moment we'll remember in the textbooks where we said our universe is flat, that we're not going to end up in a big collapse, that we don't have a limited time, that it will expand forever, they said. These results were later confirmed with data collected by NASA's MAP probe, the European Space Agency's Planck probe, and measurements made with the Atacama Cosmological Telescope. Evidence about the flat universe also appears in studies of what is known as critical density, which indicates that it is just below it, meaning it is flat and will expand indefinitely. And one more way to find evidence is through the isotropic line. If it's flat, it looks the same from all angles. The research found this with an accuracy margin of 0.2%. Still, we cannot rule out the possibility of living in a spherical or hyperbolic world. Although all measures are being taken, there is always the possibility that what happened to us for centuries with the Earth could happen, at the scales that could be observed. Its curvature was too small to be detected, which is why it was believed that it was flat. The larger a sphere or saddle is, the flatter each small part of it will be. Therefore, it remains possible that, since the universe is extremely large, the part we can observe is so close to being flat that its curvature can only be detected by extremely precise instruments, which have not yet been invented. However, at the moment, everything seems to indicate that the cosmos is flat, expanding and infinite. What is striking about this world is that the answers often raise more questions. How can it expand if it is infinite? And how can it be infinite if it had a beginning? We stop here, because there are still countless questions about the universe that do not have an exact answer.